Welcome back. So when there's movement between these two large blocks of Earth, energy is released in the form of seismic waves. This is what radiates throughout the Earth. This is what we feel. This is what causes the shaking. Excuse me. So when an earthquake occurs, there's actually a few different types of larger types of waves that are created. There are surface waves, and then there are also body waves. We're mostly going to be concerned with body waves, not so much surface waves. So body waves include two different types of waves, P waves and S waves. So you'll notice if an earthquake occurs at this focus, seismic waves kind of radiate and ripple through the entire Earth. In fact, they also kind of bounce around. P waves are known as primary waves because they're typically the first wave detected at an event. So if there's some seismic station, something that measures earthquakes, P waves travel the fastest. So that's why they're known as primary waves, because they get there first. S waves are a different type of body wave. They actually move a little bit different than P waves, which causes them to be slower. So they arrive secondary waves. And then you'll get surface waves. Surface waves get a little funky, they get a little complicated, and we don't really need to have any understanding of them at all to understand earthquakes. So we'll actually focus most of our knowledge on understanding earthquakes on these body waves, either P waves or S waves. So again, there's a few different types of waves. So body waves, these travel through the Earth's interior. Again, P waves are known as primary waves. They are compressional. They travel faster, and they can travel through solid, liquid, and gas. A compressional wave compresses the Earth, and that part of the Earth moves and compresses this side, and compresses and compresses and compresses. It's known as a compressional wave. So it compresses and expands the Earth as those types of waves radiate through the Earth. So a compressional wave. We'll look at some examples in class. S waves are known as shear waves. They travel slower, but they can only travel through solids. But when they do arrive at a location, they can cause more destruction. So a shear wave is kind of the normal, what we think of when we think of a wave. They cause this kind of motion as they radiate through the Earth. And it's the actual Earth moving, not the wave itself. The wave is not, it doesn't exist. It's not a thing. It's the energy that is released that causes a wave in the Earth itself. So, but just by the sheer physics, which we won't get into, the sheer physics of how a shear wave propagates through Earth, it makes it slower, but it can only, again, travel through solids. That becomes important in a little bit. P waves can travel through solids and liquids. Compressional waves can do that. Shear waves can only travel through solids. More on that in a little bit. Surface waves, they travel on the surface of the Earth. You have things called Rayleigh waves and Love waves. Their movement is highly variable. Yes, it causes destruction as well, but as far as studying and measuring earthquakes from a scientific aspect, we don't really need to touch on surface waves at all. So again, most of our understanding and calculations and whatever we'll do when studying earthquakes will be around primary compressional waves or secondary shear waves. So when we come back, we'll talk about how we can measure these seismic waves. So in essence, we are measuring earthquakes. But before we go, let me give you part of the super secret code. It is the number 6. You got me? The number 6. One more time. The number 6. See you back here in just a second.